So hello everyone, in this video we'll be solving another LeetCode problem, and the problem name is construct the minimum bitwise array part 1. So you are given an array nums consisting of n prime integers, and you need to construct an array answer of length n such that for each index I, the bitwise OR of answer of I and answer of I plus 1 is equal to nums of I. That is, answer of I or answer of I plus 1 should be equal to nums of I. Then they have said that additionally you must minimize each value of answer of I in the resulting array, and if it is not possible to find such value of answer of I that satisfies the condition, what condition? Condition is this: answer of I or answer of I plus 1 equal to nums of I. So if such value doesn't exist or doesn't satisfy this particular condition, then you need to set answer of I equal to -1. So this is what the question is saying. The problem is pretty much straightforward. You are given a nums array. There is some nums array. For each and every value of nums of array, you need to find one value x, minimum value x, such that x or x plus 1 should be equal to that nums of I. So this is what the question is saying. So let us see this first example and try to understand in more better way. Then we will see how we can find solution out of it. So this is the first example, and this is the nums array given to us. So let's say we take this nums of I value to be 3. Now we need to find a minimum x value such that x or x plus 1 should be equal to this nums of I, which is in this case is 3. So if we take minimum x value as 1 and then we do 1 or 2, this is nothing but x plus 1, then we will get the answer as 3. So that's why you can see this answer of I for this nums of I value is 1. So for 3 we get the minimum x value as 1. Now we are at 5. Now what minimum x value we should take? According to this answer, we should take 4. So if we take minimum x value to be 4, then x plus 1 will be what? X plus 1 will be 5. And then if we do x or x plus 1, that is nothing but 4 or 5. And 4 is what? 100. And 5 is what? 101. So if you do the OR, you will get 101, which is nothing but 5 only. So 4 or 5, we get 5. So this is equal to nums of I. So 4 is the minimum x value that we can get for this particular nums of I equal to 5. Then we have the value 7. Now for this 7, the minimum x value is 3. So min x is 3. X plus 1 will be what? 4. 3, how we can represent 3 in binary terms? 1, 1. And how we can represent 4 in binary terms? 1, 0, 0. So we can write 0 here also. So if we do the OR of both of these numbers, x and x plus 1, we will get 1, 1, 1, which is nothing but 7. So for this x value, if we do x or x plus 1, we will get our answer equal to nums of I, which is 7 in this case. So for 7, our minimum x value is 3. That's why our output here is 3. And for 2, no such minimum value exists, so we are putting -1. So I hope you understand this problem. So how we can find solution for this problem? Now first is the brute force approach, and the brute force approach will work in this solution. You will get accepted because this is an easy problem and the constraints are very low for this particular problem. But we will also see the optimized approach. So first, what can be the brute force approach? So let's say our nums array is given like this: 2, 3, 5, 7. Now for each and every nums of I value, we need to find x such that this x is as minimum as possible and x or x plus 1 is equal to nums of I. So in the brute force manner, what we can do? We can try out each and every possible value of x. Now what is each and every possible value of x? Now x can be running from 1 up till less than this nums of I. Why less than nums of I? Because if you take value greater than or equal to nums of I, so let's say if you take value nums of I, so if you do OR with nums of I plus 1, then obviously this OR value will be greater than this nums of I. So there is no point in checking values equal to or greater than nums of I. So we'll be running a for loop for x with value starting from 1 up till less than nums of I, and we can check this condition if x or x plus 1 equal to nums of I. Then we can say that okay, this x is the minimum value possible. So let me just write in terms of code so that you can understand in more better way. So first of all, we are iterating on each and every possible value of nums. So for I going from 0 up till I is less than n is nothing but size of the nums array and I plus plus. Then for each and every value of nums of I, we need to get the minimum x possible. So x will be starting from 1 and x will be less than nums of I and x plus plus. Now we will check whether this x is giving us the valid answer or not, or it is satisfying the condition or not. So if x or x plus 1 equal to nums of I, that means yes, if this condition is satisfied, that means yes, this x is the minimum value possible. Why minimum value possible? Because we are starting our iteration for the x with as minimum value possible, and then we are increasing. So if we get the value of x which satisfies this condition, that means this x value is the as minimum value possible. So for this particular ith value, we can just store our answer of I equal to x, and then we can break this loop. Because we got the minimum value, we don't need to check again further for next values of x. So this is how we'll be doing this in brute force manner. And for this particular problem, the constraints are low, and also this is an easy question with low constraints. So this particular solution will also work, but let us see what can be the optimized approach as well. So this was the brute force manner. Let us see the optimized approach. So what can be the optimized approach? So whenever there is question related to bitwise operations and bit related things, so always analyze the question in terms of bits or binary. So let's say our x value is given as something like this. So x is given as 1 1 0 1 1 1 1. Let's say what will be the x plus 1 value? This x plus 1 value will be nothing but 1 addition to this x value, right? So what will be the x plus 1? X plus 1 will be nothing but 1 1 1 0 0 0 0. Okay, let us take some another example. So let's say our x value is given as 1 0 1 1 0 1 1. So what can be the x plus 1 value? X plus 1 value will be nothing but 1 0 1 1 1 0 0. So did you analyze one thing here? So from going from x to x plus 1, what we are doing? So whatever is the rightmost 0 bit, we are setting it to 1, and all the elements towards its right that are 1, we are just unsetting it. See this example also. So whatever is the rightmost 0, we are setting it, and all the values right to it that are 1, we are just unsetting it. So this is how we get x plus 1 from this x. Now what happens if we take OR of these numbers, OR of x and x plus 1? So let's say this is the x value 1 1 0 1 1 1 1, and this is the value of x plus 1 1 1 1 0 0 0 0. So if you OR this, you get the result 1 1 1 1 1 1 1. Okay, let us do the same for this x and x plus 1. So in this, x is 1 0 1 1 0 1 1, and x plus 1 is 1 0 1 1 1 0 0. So if you do the OR operation, you get answer as 1 0 1 1 1 1 1. So what do you observe from these two examples? So in this example, you can see that x has 1 0 bit which is setting in the OR operation. In this also, you can see that in x there was 1 0 which was setting in the final OR answer. So what do you observe here? So we observe that there is 1 0 or 1 unset bit in x which is getting set to 1 in our resultant OR. So this is the most important part. So what we can say from here, that when we are doing x or x plus 1, we get the result y, and this y this result y is nothing but setting of one bit which was unset in x. So this is purely observation part. This can come only if you observe this with the help of some example by yourself. This is purely based on observation. You can't get a hint by looking at the question. No, you just need to try out the operation by in terms of bits, and then you will get to know, okay, this is the thing which is actually happening in terms of bit. So purely observation based this thing is. So what we can say, this resultant y is nothing but setting of one bit which was unset in x. So x or x plus 1 is y, and this y should be equal to nums of I in order to fulfill our condition, right? Okay, now can we think in this reverse direction, or can we apply the same logic in reverse direction? Yes, we can apply the same logic in reverse direction. So initially, if one unset value of x is setting in y, so can't we unset one set value of y to get x? Yes, we can do that. If initially, let me tell you once again so that you can think it in more clear way. So in this x, there was 1 0 which was converting to 1 in our resulting y. So can't we do that there in the resultant y? We can just make that 1 to 0 to get x. Yes, we will do the same. We will do the same thing to get the x value, because x value is what we need to find. This y we already have. This y is nothing but nums of I. So we can try out to unset a particular 1 to 0 in order to get our value x. If we have x, we can simply do x or x plus 1, and we will surely get y. Y is nothing but nums of I. Now there is one more thing to check. What we need to check? We are saying that, okay, there is one set bit in y that we need to change it to 0 in order to get the x. But we actually need x value to be minimum as possible, and still we don't know which one value we will set in y to 0, because in y there can be possible that y is something like this. So which one we need to unset? This, which one? So what we can do, there can be at most 31 bits. So what we can do, we can just iterate from 31 up till 0, and for each and every set bit we can try to make it 0, and we can compare if this whatever after setting 0 we will get some value x. Now we will check whether this x or x plus 1 is equal to this y, or that is nothing but nums of I, or not. Now if this condition holds, then this x is surely the minimum possible value. Why minimum possible value? Because we are unsetting the bit from most significant bit. So if most valued bit or the most significant bit is getting unset, that means the resultant value is as minimum as possible. So whenever we are iterating from, or whenever we are unsetting a bit, a 1, when we are converting a 1 to 0, and if that x value satisfy this condition, that means that x value is obviously the minimum value, because we are unsetting the bit from most significant bit. So obviously if we are unsetting the most significant bit, then obviously the resultant x will be the minimum value possible if it holds the condition equal to y when we do OR with x plus 1. So this is how we'll be doing this particular solution. So this is the most optimized solution, which gives us the time complexity of n cross 31. So let us analyze with the code how we'll be doing it. So first of all, what we need to do, we need to iterate over the entire nums array, and for each and every nums of 5 we need to find the minimum x possible. So we'll be iterating from the 0th index, and we will go up till n in the entire nums array. This n is nothing but size of nums. Now for each and every nums we will try to unset each and every set bit from the most significant bit. So we will be running a for loop. J will be starting from 31 and j should be going up till j is greater than equal to 0 and j minus minus. Now we need to check whether a nums of I value is set or not. So if nums of I, if its jth bit is set or not. So this is how we check whether a bit is set or not. Basic bitwise operation, nothing else. So you should you must know how do we check a bit is set or unset, or how do we unset a bit. These are the basic stuff that I hope you already know before watching this tutorial or before watching this solution. So this is how we check whether a particular bit is set or not. So if this particular jth bit in nums of I is set, then what we will do? We will unset it. So after unsetting it, what we will get? We will get the value of x. So x will be nothing but nums of I, and this is tilde. This is tilde sign 1 and then this. So this is nothing but we are unsetting the bit. We are unsetting bit. So this is what we are doing. So if we unset the bit, that means we get the value of x. Now if we have the value of x, we just need to check if x or x plus 1 is equal to nums of I or not. So if this is the case, that means we got the minimum x possible. So just store answer of I equal to this x and break from here. And yeah, subsequently we will be doing this for each and every value of nums of I. So what we are doing, let us summarize this again. So what we are doing for every value of nums of I, so for every nums of I, what we are doing, we are trying to unset a set bit. That means we are trying to convert each and every one to 0 from starting from most significant bit and going up till least significant bit. Now after unsetting it, whatever value we get, that value is nothing but x. Now if that particular x holds the condition of x or x plus 1 equal to nums of I, that means this x is minimum value possible for this particular nums of I. So this is what we are doing in this particular problem in the most optimal approach. So let us see the code now. So yes, this is the code. So first I have declared the size of the nums array and I have declared the answer vector. So this answer vector is initialized with all value to -1 initially. So if for some particular nums of I, if the x value exists, then we will replace this -1 with x. Otherwise, if it doesn't exist, we will just go on. In the end, if we cannot find a particular x value, then it will remain -1. So this is doing because in the question they have said for a particular nums of I, if x value doesn't exist, we need to return -1. So that's why we are initializing it with -1. If we get the answer, well and good, we can just replace it with x. Otherwise it will remain -1 because we didn't get any x value. So what we are doing next, we are just iterating on each and every nums of I. For each and every nums of I, we are trying to unset a set bit starting from the most significant bit. So we are checking if this particular nums of I is set or not. If it is set, we are unsetting it. So we are unsetting this. So this is how we unset a bit. And after unsetting it, whatever value we get, that value is nothing but x. And if we get the x, we can just check the condition if x or x plus 1 is equal to nums of I or not. If it is true, that means our answer of I is nothing but x, and this x will be the minimum value possible. And if we get the minimum value, don't need to iterate it again, we can just break it from here. In the end, it will happen for each and every value of nums of I, same operations will repeat, and in the end, whatever answer we get, we are just returning that. So in this, we are our time complexity is nothing but n cross 31, because for each and every nums of I, we are running this loop at most 31 number of time. So that's why our time complexity is n cross 31. So I hope you learned from this solution. Thank you for watching.